Thanks, Amy. No, we don't actually test anything, do we? It's yeah, we just make it up. No, we are supposed to be testing stuff, and that's why I'm here to talk about that. I guess I could start out by saying thanks, Effie, for the last talk, because that was something I knew nothing about. I don't know if anyone had done anything about compliance as code, but it was just certainly something that I'm like, wait, that's a thing? Okay. Because I always look for what's the new things bits are, especially in cloud. So thanks, Effie. So I hope you're having a good time and you enjoyed your lunch. I'm now here to tell you what to do with cloud testing. And we got some good stuff coming up. Alrighty, so I am, bear with me here. There we go. So that's me. Hi, I'm Lars. So my profile says that I work for Pluralsight as a training architect, and now I'm telling you that I work for a cloud guru as a training architect. Actually, to make it a little bit more complicated, my HR profile for about 6 months said that I was a training architect, so I'm just going to go with that. So I'm going to go with training architect, and I work for ACG, and then we're all really confused. You're welcome. No, Pluralsight acquired ACG, and it's now in the process of merging something. I don't know. I just do videos. But anyway, Microsoft MVP, it says. That means you get stickers because I'll talk about Microsoft stuff like today. So I think that's enough about that. Yeah. Anyway, what do I do? So this is part of my job, believe it or not. I actually create videos on Azure and llamas. You will not believe how hard it was to get that t-shirt on that llama. Unbelievably difficult because they run around and everything. But if you want to know more about that, I have actually got my bot sending out tweets as I talk about things. It's really useful. So if at any point throughout the talk today, the next 45 minutes, you might want to know a little bit more about some of the things that I'm talking about, there might be a tweet for it. So go and check out my Twitter account and you can follow along there, and it gives you a bit more context about some of the things, because there are an awful lot of things that we could cover and I'm only choosing a few of them, and it's going to go pretty quick. So that's why that's there. So we want to use Twitter, but you can also do it after. So there's like a reference. Yeah. And of course, questions. So I love questions. That's part of why I do these things, is that I want to hear from you. And obviously I would like to be in front of you in the flesh in Perth, but that's not going to happen because reasons. So we're here. Now you can use the questions and answers thing on Hopin on the actual, event platform. Please do that. Michelle's going to curate them and make sure that I answer them at the end. So there'll be time for that at the end. Normally I'm happy to take questions throughout, but because of the disjointed experience with people not actually being present, it's a bit weird. So we're going to do it this way. So that's kind of where, I think that's all the housekeeping. Anyway, so I'm going to start with developers. And I'm going to ask who here works with developers. And normally I would see hands come up, obviously. And if you know a developer, you are a developer, then you should be testing your code, right? And if you're not, well, actually, I'm usually say, if you tell me that you are testing your code, I know you're lying, because no one does. And there's reasons for that historically, but today, to be honest, there's not really any excuse not to test your code, other than just pure laziness. So yes, you are all liars if you say you test your code. I stand by that. Yes. Now, when I put together this talk, I made a whole lot of research into trying to figure out, well, what is the literature around this? Like, how do you test your code? And I actually found quite a few. Believe it or not. And this is some of my favorite. I just picked out a few. So there's this one, Excuses for Not Writing Unit Tests. That's a really good resource to how to avoid writing any kind of unit tests because they're annoying. There's Hoping This Works. That is an approach I've used many times. Solutions that, it says here, that might fix the problem without breaking anything. And then there's Practical Testing. So just clicking around. That's a very popular way to test things. Just click on everything and see if it works. And then there's my absolute favorite, which works every time, Commenting Out Failed Tests, because who needs them, right? And then, of course, I've also made some further sort of statistical analysis of where we're at. And this is what seems to be the generic or general developer testing approach is this. Most people will actually say, what do you mean testing? And usually it's testing is someone else's job. Now, of course, I'm making fun of all this, but it's not entirely untrue, to be honest. testing is something that we as developers, yes, I'm looking at all of you, even developer managers, is something that we just kind of go, I'd be right. Or we say, oh, automation will pick it up, you know. And then when it comes to cloud, Azure and specifically Azure, because that's sort of what I do, right? Then it becomes even harder because you go, well, it's in the cloud. It's how do I even test that? Yeah, many excuses on why not to test cloud. So I've picked out a few excuses throughout this talk, and I'm going to try and answer some of them with things that you can actually do in Azure to test your code, practical things that you can do right now. Yeah, so let's get into that. So who tests PaaS anyway? So platform as a service. If you're not familiar with PaaS as a concept, it's where the platform is the service that you pay for. So this could be something like Azure DevOps. It could be, development platforms like, Visual Studio Online. Well, that's not what it's called now. Whatever it's called, the Visual Studio, they change name all the time. Those things that are PaaS enabled. So also an app service on Azure, that's a PaaS service. And that's actually what I'm going to talk about, is the app service. Now, this is one of the most used services on Azure without any comparison. There's VMs and a storage, of course, and then app services is way up there because that's how kind of you host anything web on Azure. Websites, web APIs, even Docker containers with a web front end you can host on that. So that tends to be let's say, low-hanging fruit that we can start testing. And there's two things in particular that I want to point out with today. It's staging and A/B testing. Now, here's a little video because I don't trust live demos. So bear with me while this runs. Now, this is my own account on Azure. This is LlamaCam. So Amy wasn't lying. There is actually llamaCam.com.au. It is a thing, not really related to this talk, but this is an app service. And in here, there's something called deployment slots. And you may or may not have heard of them. They're very popular. They're very common. Usually they're used for a particular purpose, which is what I'm going to show you first here. So this is there's currently one deployment slot. You're always going to have one. Your website's going to live somewhere. So we can add a slot to it. And that is it's on the same app service plan, which is the same as a server or a VM. So this app service plan can have multiple slots, so multiple instances of this website. And you give it a name like staging, and you can copy either the configs, so that's everything that makes the website run, or you can have like a test config if that's what you wanted to have. And we create this new slot, and that's as easy as that. We now have a complete duplicate of that website running inside of the same app service plan. So we have essentially two websites. Now one says production on it. We'll just let it load here. When it comes up, it says one says production. That means that's the one that people are seeing when they go to llamaCam.com.au. And the other one is the staging website. And staging is like the most fundamental thing for testing things. We push everything to staging, see if it works, and then we can swap them. Like I clicked on swap. And that means we can swap the two slots. So staging becomes production, production becomes staging. And we do it, and it goes like this instantly. So it's a really simple way for any small project to test out your app service before anyone even sees it. Now, one thing that we can do, sorry, I was moving the mouse and it showed the progress bar. There we go. If I go back and I look at this llamaCam staging slot, you can see here that it has its own URL. So you can access it directly as well. Now you can control that with permissions, obviously, but you can have that publicly available. So if you had like a QA team or another person needs to look at it, there's a public URL for that. So that's a really cool thing. Now, one thing most people don't know you can do with deployment slots is that on the right, there's a traffic percentage number. And that number says how much of the traffic goes to each of the slots. So instead of having a staging slot, I could put in, say, 30% of the traffic would now go to staging. And this is what's called A/B testing. And this is a fantastic way of testing one little change at a time. So if I move the buy now button up to the top rather than the bottom, does it increase my sales? Stuff like that. And you can do that this simply, like just deploy two different versions of the same website with a small change, direct traffic 50-50, 20-80, whatever you think is right. And then you have A/B testing. This is usually, it has been traditionally something that was really, really tricky to set up because you needed two virtual machines, or you needed two instances, or you needed two of everything. But now you can just do it like this. It's very cool. Very, very, very simple to do, and highly recommend using that if you have things that you want to test out with a small audience. Quite rudimentary and quite, simple really, but it works. Alrighty, so hopefully you're putting in questions because I can't actually see the questions right now, but I'm hoping you're putting in lots of questions, right? Questions, come on, ask questions. Okay, so next question is, or excuse. Oh, I don't want to start that again, sorry. Come on, there we go. Next excuse is usually, well, if it fails, I'll just rebuild it. Someone else will rebuild it. And the interesting thing is for Azure, this is actually kind of a approach to testing your infrastructure. So there's something called Dev Test Labs. A great name again for Microsoft, because naming is hard. But Dev Test Labs is kind of what it says. I don't know if it has that much to do with labs, but anyway, I'll show you in just a second. Some of the features of this is that you can set up a whole environment just for testing, and it gives you, as it says, provision of environments, it gives you quotas and policies and shutdowns, and you can use every single image almost there is on Azure to test this. And this allows you to create entire environments with virtual machines. So now we're talking IaaS, infrastructure as a service, where you can provision these machines for people that need them. I'll show you how that works as well. So here is, again, the portal. And is that playing? Oh, there we go. And this is me just creating a new Dev Test Lab instance. So these are free. You can create as many as you want. You basically just pay for the resources that you use, your storage or your VMs or whatever, like you would normally. So in here is a Dev Test Lab. I can add resources. Sorry, let me just create the Dev Test Lab first. It's as simple as putting it into a resource group, giving it a name, and off you go. There's really not much more to it. I'll give it a name here. Woo! Dev Test something. Now, I've used Dev Test Labs before in environments where I didn't trust the developers, because who does, right? Now, what it does is it gives you like a playground, like a sandbox for developers that they can just go and use. So when you deploy your Dev Test Lab, you put all these resources into it, and then you give access to the users, being usually your development team, to go and use these resources that are in here. So we just go to the resource, and there's a whole list that we're going to add a machine here or add an image to it. So you can, there's a million here. You can see the scroll bar, how small it is. So we're just going to choose one of the first ones here, your Ubuntu server. And that will then, you just create it like you would a normal virtual machine, because you can, there's some things you can manage with it. Obviously, you don't get into changing, networking connections and all that stuff, because it's less relevant when you're just testing the VM. But give it a username and password, or however you prefer to connect, whether you use SSH public key or username and password. You can even choose the type of drive it has. And then, of course, you can choose artifacts, which I apologize. I realized this like half an hour ago. That was a bit quick. Artifacts are the programs and the bits and pieces you need on the VM to run your code. So in this case, I've added Node.js, and you can see it's creating it. And now I have a virtual machine. So that is a virtual machine like any other virtual machine. The difference is that it's inside of the Dev Test Lab environment. And that means that you can almost not mess it up. Like you're not going to suddenly have something that goes out on the internet or is public available or anything like that. It is just a VM that is inside of Dev Test Labs. There's a few features here like auto start or shutdown, because you do pay for it running. So I would recommend having auto shutdown on it. That's probably a very good idea. And then you can also then, see up the top, it says unclaim. So when you're done with the VM as a developer, you can then go, hey, I don't need this anymore. I'm going to unclaim this VM, which means I'm going to put it back in the pool of Dev Test Lab for another developer to use. So if I go back to the Dev Test Labs, you can see now there's a claimable virtual machine. And that could be many. That could be all sorts of things. It could be Windows, could be Linux, could be Oracle, it could be a SQL Server, whatever it is that VM image does. That could be something that you create. So obviously you can also lock it down. I've talked about policies. That's just a list here of how many different ones there are. If I scroll down, you have a look at how many different VMs there are. But you can lock it down with policies. So as an admin, you can make sure that people don't just willy-nilly create massive VMs or lots and lots of them, but just claim them and unclaim them, or just install tools on them. It is that that configurable. So that's quite cool. So I would recommend using that. Again, the actual dev test lab instance is free. And if you're not running the VMs, if they're shut down, well, they don't cost anything either, right? So it's a very, very cost-effective way of testing your VMs and everything in the cloud before it goes into the world. So yeah, again, usually not a lot of people knows about the dev test labs. Maybe it's just a silly name, I'm not sure. Yes, so, all right. And what am I doing here? I forgot what this one was. Oh, this is the same one. Sorry, there we go. I thought there was only one. So that was the IaaS and the PaaS. Now, if you've done anything with cloud, whether that's Azure or especially AWS, Azure DevOps, a lot of different tools use YAML. So usually it either uses YAML or it uses a JSON notation. That seems to be most of the modern tools, the way that they work. And they're similar in sort of their declarative languages. So you sort of just write what you want. You declare what things you need. And they're really cool for that. The YAML language is a little bit daunting at first if you come from like an actual programming background, if you've done Java or C# or even JavaScript or any of the other scripting languages, because it's sort of weird that you're not programming as such. You're just declaring what you want. So, hey, I need a VM. It needs to have this OS. And then all of that becomes translated into actual code in the back end, or Azure does that for you. And then it just creates everything for you. So anyway, but I've often heard this as a testing excuse. Well, it's just a YAML file. Like, why would you even need to test a YAML file? And the reason that you need to sort of maybe not test the YAML file itself, but the output from it is that, well, YAML files are really powerful, right? And you can get into a lot of trouble if you put stuff in that you didn't realize exactly what it did. So there's Angry Cat, by the way. I'm going to then talk about Azure test plans. But first, I'm just going to have a drink. Yeah, don't forget to put questions in the thing. All right. So Azure Dev Test Plans. This is part of Azure DevOps. If you're not familiar with Azure DevOps, you might have heard of Jenkins, which is another kind of DevOps tool, deployment tool. There's what's the other one? What's the one from Team? Is it Team City? I think that's what it's called. That's another one. They've sort of done similar things. Now, Microsoft with DevOps has tried to put everything into one tool, which is why it's called Azure DevOps, but it's not just for Azure and it's not just for DevOps. It's yeah. Anyway, I think I have a whole talk on naming. But Azure DevOps is a deployment and project management tool that is actually quite powerful. So with Azure Test Plans, that's one of 5 areas from the Azure DevOps tool. The others, is like, code, which is where you have your like GitHub, your repositories, and there's artifacts, which is your like your NuGet. Then you have board, which is like your project planning, and then there's pipelines, which is very important. That's how you deploy everything out to continuous integration, continuous deployment. Those sort of paradigms are done through pipelines. Anyway, Azure Test Plans. You can use planned and explorative testing. So we're not going to go too much into explorative testing, but you can actually record test scenarios and record the bugs and whatever through this tool. You capture a lot of data about the tests that you run. It works both for web and desktop, which is kind of neat. You can actually have your code up into Azure DevOps in the repositories and have and run the desktop DLLs and everything through it as well. And end-to-end traceability, which is a marketing term that means, hey, you can see exactly what happens the whole way through. So I have another little snippet here of what that looks like. So this is Azure DevOps. This is the tool. It may look slightly different now because it changes all the time. It's one of these things that as an old person, you've got to go, stop moving my cheese, because a lot of modern tools just change all the time. If you use Visual Studio Code, that changes every month. There's a new update every month with new features and new things, and they move the menu about, and there's new shortcuts and everything. And that's all lovely, but it's really hard to keep up. So this is Azure DevOps. You can see on the left there, just on my screen, you can see the 5 different things that I talked about. There's boards, repos, pipelines, test plans, and artifacts. And I'm looking at test plans. So I can add test cases to this. Obviously, that's kind of the whole idea. You should have a test plan for your project. So if I run this, you can see that I can create new test cases. So in this case, I'm going to create a new test case from existing tests. So in this case, I've preloaded some tests into the system, and I'm going to run a query to find them, because you could have thousands of tests. Now I know you don't, because you don't test your code, but you could have thousands of tests. So I'm going to choose these as an example. And then what that does is it brings them into a test plan, and that plan is what runs at whatever you define. So that could be every build, it could be after every other trigger from a certain tool, it could be whatever you want it to do. And you can also execute the plan, of course. So this would be, run for a web or a desktop application. You can see there I can check one and I can run it. I'm not going to do that right now because it takes forever to look at that, but it will run the test. It gives you an output. It can report on the results so that whoever needs to know that things have failed will know about it. It can create tasks automatically so that when something fails, it becomes a task for a developer to do. And even for your manager, it has charts and it has pie charts. Yes, so they can create charts, I guess. That's great. But Azure Dev, Azure test plans in Azure DevOps is a feature of DevOps that is, again, underutilized, because most projects uses it for boards, repos, pipelines, and sometimes artifacts as well. It's rare that I see anything to do with this. And it could be because you run XUnit through something else. Could you have other tools that do it? That's cool. They can actually plug into this as well, give you results through Azure DevOps as well. But that's Azure DevOps. Now, I know I'm talking fast and there's a lot to go through. So please, do use the question thing if there's something you want me to clarify at the end or anything. It's just that there are so many things you can do to test your code in Azure that I'm kind of trying to get through all of it. Now, here's a tool that is very cool, that is really useful, and one that I happened to find through a Google search, I think. It was that random. This is the Azure DevOps Demo Generator. And this is, as you can see, it's hosted .azurewebsites.net, which is the standard default domain you have for any app service on Azure. So I'm not entirely sure who's made this, but they're genius. What this does is that you log in to this website with your Microsoft account, like you do with anything Microsoft. It hooks it up to your Azure DevOps instance, and then you choose from 6 or 7 different projects or scenarios. And those projects or scenarios are then loaded into your Azure DevOps as a new project. So it's not going to clutter up anything that you already have in there. It's not going to mess up your existing systems. It's just going to create a new project that you can then basically click around on and press all the buttons to figure out. And that's how I tested the dev test labs, not dev test labs, again, naming the test plans for this particular presentation was I used this tool. And it gives you everything. It gives you all the pretty graphs so you can see how it should look and what it can do. It's a very cool tool, and it's sort of, I've never seen it mentioned anywhere, and I don't know why this person hasn't got more credit than they do. It's fantastic. Because Azure DevOps is such a huge platform, it has so many different features and products even within it. It has 5 distinct products pretty much. It's very hard to get enough data or the right data to figure out what everything does and how you should use it. And this just does it. So again, here's another way to test the platform before you do your tests. So test before test, just to try and figure out what it does. It's very cool. It's fantastic. Right. So that's the Azure DevOps Demo Generator. Yes. And if you check my Twitter account, I think my bot just tweeted that link as well. So you go click on it. Check it out. All righty. It's fun, isn't it? I still wish I could see people. I can see Amy, but she's not looking at me. So like she's not paying attention. Oh, I can see Michelle as well. Everybody's waving. Hey, it's like there's like a secret back room for all the speakers and stuff, and you can see Effie's waving as well. Anyway, that's just so I have someone to talk to. Sorry. Okay, next question. Well, there's no server and serverless. Huh? Right? So the excuse there is that, well, how are you going to test that? It's serverless, right? And again, just really terrible excuse. Because serverless, yes, of course, it's not serverless, it's someone else's server. I think we've all heard that before. It's like there's no cloud, it's someone else's computer. Well, of course, serverless is not serverless. Like there is a server somewhere, it's just that you don't have to manage it. But that doesn't mean you can't test your code on serverless. So, and of course, the main thing with Azure is functions, right? That is the number one serverless technology there is on Azure. It's not the only one. My favorite, actually, I mean, I like functions because they're very powerful and they're very easy to use and set up and everything, but I like logic apps. I'm kind of a visual person. That's why I do a lot of videos as well. And Azure Logic Apps, if you've never looked at them, it's sort of like your mum could figure it out. Like it's really straightforward, and it's very powerful getting your, as an example, getting attachments from an email account into a database, right? Which normally is an awful lot of code and triggers, and that takes about 10 minutes on Azure Logic Apps. Anyway, I digress. Azure Functions is serverless, blah, just said that. It is what the cool kids are doing still. So they're not that new anymore. I think when we talk about new technology, it's not as new as other things. I don't know what's new, to be honest. I can't keep up. But Azure Functions is now version 5 or something like that. It's pretty well established. And how do you think you test your serverless applications, right? It's actually not that difficult because it just works like any other project in Azure, in Visual Studio, or Visual Studio Code. So I like Visual Studio. Some people like Visual Studio Code. You might like, I forget the one that, JetBrains make. Anyway, that's a good editor as well, but I just haven't used it. But whatever your editor is, whatever your IDE is of choice, there is a way that you can install Azure Functions locally. So what you do is you install the runtime locally. So your Azure Functions runtime runs locally on your machine, and you can then run your functions on that. Now, of course, sometimes you have to connect to other services and whatever, but that's what stubs are for. That's how we do tests on things that don't exist. We just pretend they do. But you can do everything locally, right? You don't have to test your Azure Functions on Azure itself. It is possible to do it locally. And then you just do tests like you would any other test. Oh, wait, you don't do testing, do you? But anyway, there's many frameworks that are called XUnit, NUnit, there's Microsoft Test. I'm just talking the .NET world now because that's where I live, but whatever world you live in, if Java or whatever, there's always a testing framework for you, right? And then you use that to test your Azure Functions. And yes, you can write Azure Functions in Java as well. Yes, you can, or Node.js. Or Python, whatever your language of choice is, there is a testing framework for it, and there is no excuse. Just use it. But that's sort of often I see developers missing that connection. Like I'm doing serverless. Yes, I'm creating another function, and before you know it, they have 100 functions, which is great. And then no one knows where they are, no one knows what they do, and no one knows if they're broken. And the idea with that is that you put tests around everything. Now, there is something called test-driven development, which has been around forever, TDD. And you might not be into that, where you actually write the test first, and then you write the code to pass the test, which is cool if you're into that. I've never found it to be my approach of choice for various reasons, but you can do that in whatever tool you use. So again, I'm banging on about this, but yes, if you write serverless code, whether that is Azure, AWS, GCP, whatever it might be, make sure you test it, because functions are notorious for being neglected because it's so easy to write another one. And then you suddenly have functions that you forgot you're using, or you did one as a test that accidentally got pushed to production. If you have tests around all this, and you can do tests as well, by the way, for whether something is in production or not, you can. But if you have functions, make sure you test them. If nothing else, to keep track of them, to be honest, because they grow like buckwheat. Hang on, buckwheat doesn't grow. Anyway, you know what I mean. Right. So this is always something when we talk about cloud computing. Well, it's someone else's computer or whatever, someone else is going to do that. By the way, do you like my animal pictures? I didn't know what to put for this one, so I have like little birdie thingies that are shouting at each other. I don't know if that makes sense. Anyway, I like them. But because it's someone else's computer, it doesn't mean you can't do anything to test it, right? It just means that you can't press the off button or you can't install new RAM. But you can absolutely test your programs on it. And a lot of this that I want to talk about today is performance tuning, specifically for databases and also inside of something called Application Insights, which is probably the most important tool on Azure as a developer. And I stand by that, Application Insights. But performance tuning is, there's the old saying, I still think it's true, I'm not sure, but if your website is 1 second slower than a competitor, you'll lose 7% of revenue, something like that. I think that's what the quote is. And if your website is 3%, if it takes your website 3 seconds to load, it's something like 50% of traffic that gets lost, right? Performance is super important, especially in cloud as well. Like, it's got to be performing, otherwise people just won't use it. So let's have a look at the database. So this is part of an Azure SQL instance. I have blatantly stolen this from Microsoft because that was a very pretty picture. And I couldn't make one that looked just that good myself. But that's also why there should be a link on Twitter to the docs for this particular graph outline thing. But what it's showing here is that there's a performance graph on the top 5 queries of CPU consumption, right? And when we're talking about performance, a lot of that is CPU consumption or CPU time, because the longer something takes to process, the slower it's going to be, right? And that might be all right in certain circumstances, but for the majority of cases, you do not want long CPU time. You can see the yellow one here, whatever the yellow one is, that's bad, right? It's taking up massive amounts of CPU. And what it also shows you is that you have spikes. So it's like, oh, hang on, why is this spiking over the last 24 hours? It's like we have a buildup and then something gets killed. And so you can use this as an analysis tool as well. So it's not just for performance monitoring, but you also, essentially you can evaluate what's happening with your processes by just looking at these pretty pictures, essentially. But yeah, go read the article. If you're into database optimization and performance monitoring and all that, there is some really cool tool in Azure that you pretty much get for free. If you're paying for a SQL instance, you get all of this for free. It's just a matter of going, using it and understanding it, right? And the performance overview is one of them, just one of them. You can see there's performance recommendations as well, which we'll get to. I can't remember now, but otherwise put in the comments, in the questions. Ask questions, people. Oh, I need water. All righty. So we've got 10 minutes left before questions. So the other thing that which I just mentioned is the applications insights. And now here's another video that I, again, blatantly stolen from YouTube, done by Microsoft, because this is one of the things that's really hard to do and fake, because you need so much data in a certain way, right? So this is probably the best example I've seen of how to use application insights for performance tuning your application and figuring out what's actually gone wrong. So let me just start that while he goes through it. So application insights is something that comes as part of almost a lot of services. I wouldn't say every service, but a lot of services on Azure. You enable it and it collects vast amounts of data about your application or about your instance or your service or your resource. In this case, we've collected data about this particular app service here. So there's an application map that shows you how much CPU time is actually being used by certain things. So this instance here is using, I think that's what it says, it's 68%. I can't see it properly, sorry. 68 alerts, I think it is, for that particular application. So what he does is he drills into each of the processes and sees just how much time the CPU is actually using on each single execution of a query or of a request. There's a ton of graphs that shows you trends. Again, this is what I talked about before. You want to have this visual because it shows you can see there's a spike here. And why was there a spike? Like, what happened at that point in time? And it's very easy to see that when it's visual. If it's all in text, it's a lot harder. But there's also logs queries. The application insight logs are, well, actually, this is logs for the entire app, not just application insights. We're going to look at the virtual machine, and we're going to chart the CPU usage trends here as well. So you can run this through the log analyzer, or this log analytics dashboard. God, I can't remember the naming, but this thing here, where you write sort of declarative SQL-ish commands to get the data out. And you can see the spikes here, right? So he's going, if you watch the video, please do. He's going through saying, well, hang on, why are there spikes here? Let's try and drill in and find out what these spikes are doing. So we're going to look just at the logs for this particular application. And then you have saved queries, you have a whole bunch of stuff. Application Insights is probably a whole day's worth of talks in itself. It is such a powerful tool. It does so many things. And if you're not using it, you're just not debugging your applications efficiently, I think is probably the right way to say it. It is incredibly cool. I really like Application Insight is my friend as a developer on Azure, especially when I'm running something like Azure Functions. If I'm running, because your function app, which is what the functions live inside, can also have application insights. All your app services, everything can have it. So, oh, did I just pause that accidentally? Sorry. You can see here, there's a whole bunch of these requests that are using a massive amount of time. I don't know if you can see my mouse here, but there. And the actual CPU time for executing is only 38 milliseconds, right? So there's something wrong. Like, what's going on? All those things are so easy to find. Well, I shouldn't say so easy. They can become very clear quickly when you get to the right part of Application Insights, right? And again, we're back to the application map here, which I like. It's sort of a nice way of displaying where things go and what resources are being used and what queries are being run. But that's almost a must. And often it's not enabled by default. You have to go in and actually click the button and say, hey, I want to enable Application Insights. So do that. Yes, it will save many, many hours and possibly straight jackets and padded cells. Anyway, so that video should also be on my Twitter, by the way, if you want to know more about that. And then finally, we have like the big one, really. And that is, well, Microsoft should be doing the testing. I'm paying them for the service. Why are they not making sure that everything runs correctly, right? What am I paying them for? And this is managers going, why are you doing testing so much? Like, we pay the service, whatever. And yes, you pay Microsoft to make sure that these services are available and running, but you don't pay them to fix your idiocy when you say +2 instead of +1, right? They can't monitor everything. So there are some very cool recommendations that Microsoft has for testing your architecture. And these are quite complex, but I want to go through them anyway as sort of the last thing here. We sort of build up to the more complex part of it with log analytics, and now we're testing the architecture. And again, absolutely ask questions. Like these, I would imagine, would have a lot of questions of, well, why'd you do it that way? And again, this is just a recommendation of how you could do something. So I'm going to start with IaaS, so infrastructure as a service. And this is Microsoft recommending a way to essentially build up an architecture for making sure that you can test your IaaS implementation properly before it goes out to production. You can see there's little numbers on it. So I'll quickly walk you through that. I've got 3 examples of these. So this is the first one. They have put Windows Virtual Desktop on there, which of course they want to sell you that as well. But it is kind of cool because Windows Virtual Desktop is an entire Windows instance running in the cloud. So you could set it up so it doesn't run locally, but just run. So you can run Windows from your Windows machine to test. Anyway, Windows Virtual Desktop gives you an entire development environment in the cloud. And it just means that you can log out and in, and you don't have to worry about everything on your computer. And then that goes into the source code, which if you use Visual Studio, as the example does here, your source code usually comes from GitHub repos. And then that code goes into Azure Pipelines, which is a way of deploying. I've briefly mentioned that before. So you're deploying your code, and then any errors or anything that comes out of the pipeline run, any triggers or any reports, whatever, that goes back into Azure Boards, and then that becomes tasks that goes into Visual Studio, and you have this loop, right? But then when you're happy with it, then Azure Pipeline will push it down. So now we're at number 6 here, would push down the code to your dev test subscription. So that's an Azure subscription. And you will have various resource groups. That's what these boxes are here: development, QA, staging. and the code will be pushed into the development arm of this. So in this case, there's an Azure Dev Test Labs, and there's some VMs there. So you're pushing the code to those VMs on the test instance, and then you can use it. And that's what's usually called continuous integration. Everything gets pushed on there. Then when you're happy with a build that is on the test environment, you can then promote that into the QA. And then when they're happy with it, they promote it to staging, and then it goes through. And then when you're happy with that, then Azure Pipeline will actually push one to production pre-prod. Now, you may have one or more of these arms. This is obviously Microsoft wanting you to do it the best way that you possibly can and spend the most on Azure infrastructure. But it's not a bad setup, and it makes sense if you follow all the arrows and the numbers and everything. So that's IaaS. Then there is PaaS, so platform as a service. So that's like app services, or actually Azure DevOps, I would say, is a PaaS system as well. Could also be SaaS. It's a little bit on how you decide to define it. But in this case, for PaaS, we're talking about websites now, essentially. Again, you have, say, you use Visual Studio Code, you have this development loop where the code goes into GitHub repos. And then because this is Microsoft, they've added GitHub Actions. So this does similar thing to the pipeline on Azure DevOps, the GitHub Actions. You could use that to, make sure that the builds are all running all right. And trigger then builds that go into your dev test subscription. Again, you'll have a development environment, and then you'll promote that to QA, promote it to staging, etc. Hopefully you can see a trend here. This is often how many of these systems are built up, and it's the same in the cloud, whether you're on-premise or in the cloud. You'll have this development loop, which makes sure that the development is happening, obviously, and then the code gets pushed to a development environment where you can see that it's working, right? So you go from local, which is the development loop, into the development environment, which is usually on the cloud. And then QA, staging. Some people have a showcase. So if they have clients that want to follow the development, you push particularly good builds to the showcase build, or so showcase resource group and all the resources there. But it's the same idea. Now, all these icons in the middle means that you're using Key Vault to manage all of your keys to all the different environments, so that we don't have passwords flying around everywhere. Azure Active Directory is used to manage who has access to each of them, whether that's people, users, or applications. You can use Terraform. Terraform is a tool that you can use to build infrastructure as code. So sometimes, I don't know why they put that on PaaS, but anyway, and Azure Monitor, which monitors everything and gives you recommendations on what to do next. So just before we run out of time, because I can see Michelle is just about ready to jump in, we just have the microservices one, and this is probably the most complex. I am not a microservices person. I find it very confusing to develop for microservices, but there is a way that you can develop without losing your mind, and this is an example of that. Using basically what they now call local process with Kubernetes. It used to be called dev test spaces, and it's a way to run your container instance locally while connected to the cloud. It's actually very, very clever using namespaces and magic. And then you can, again, develop your microservice. You can put it into the ecosystem of microservices that you have. And then you can eventually test it. It goes through, and then it gets pushed to the production registry, which is number 9 here. I'm skipping a bit ahead. And then that becomes the thing that everything pulls from, right? So with containers, you have a container registry where everything gets pulled from when you create new instances for it. That was probably the very, very fast way of saying that. So I think my point with rambling on like this about many, many things for about 43 minutes or something, 44 minutes, is to stop with the excuses. Seriously, just do the testing, okay? You will be better off. If you have managers to say, hey, are you sure? I just push back, say, yes, I need to do the testing. It will save your backside in the end, absolutely. So that's all I had. Thank you very much. And I think hopefully we have questions. Michelle's looking keen.
We do have questions. Thank you for your constant prompting, which saved me from having to do it. So first question is from Lee, who says, can you recommend any cloud scale load tests, i.e. more than 5,000 concurrent users, ideally 50,000 plus?
It's interesting because Microsoft or Azure used to have their own load testing tool, and it was almost like it was part of, I can't remember if it was part of application, of app services or VMs or something. And it just disappeared for some reason. So I don't know if it was incredibly difficult to run or something. So you're going to have to go with third parties, but I'm not sure which one is the best one. I do want to know if anyone knows, put it in the chat and Michelle will let us know, but I'm not sure which is the best load testing tool, but it is important. I agree. And it's something that doesn't cost a fortune, because if you suddenly scale up to 10,000 VMs, yeah. So it's the
or
best
maybe
answer
you
I
can
got.
put it on your Twitter with everything else, Lars, when you find out.
Yeah, I'll ask my bot. Hang on.
It's going to be fun watching the video of this later. Everyone's going to be scrolling through your tweets. Okay, next question is also from Lee. Linking your talk and Kat's talk on chaos engineering, can you propose any tools or strategies to test your production system? i.e., if I perturb my production system like this, it will behave like this.
Oh, right. Well, immediately what comes to mind is the A/B testing in app services. So if, let's say, your production system is an app service, you could absolutely funnel some of the traffic to a different slot on that app service and see kind of what happens, right? Because it's very easy to kill it and get rid of it if it doesn't work. So we're talking about testing production, aren't we? Really? That's sort of what I'm hearing. Yeah, Lee. I can see Lee, by the way. I can see he's nodding. And testing in production is an interesting idea, because we always go, no, you shouldn't test in production, but we all know it's going to happen, right? Everything always goes wrong in production. And I don't know, theories and strategies, don't do what Microsoft does and let users do it. I think that's probably the best thing. That's usually what happens. They just launch something and they go, hey, here you go. No, I don't actually. I don't have a good answer to that. I think it's a bit of a niche topic. I'm hoping that someone has a good strategy for that, but I don't know. I'm sorry. I'm not too much into that. Good questions though, Lee. Thanks, man.
I'm on mute. That's good. Lars here giving away all of our backstage secrets. Yes, we have a gong. When people run over, we hit the gong. There's a hook. It comes and drags them off on stage in real life. We can't do that online, so we have a gong. Yeah, it's all happening. All right. Next question is from Anonymous. How do you do integration tests for your functions?
Integrate. Oh, that's a good question. I think integration tests. Yeah, with functions, because they're so specific. Like hopefully a function. I usually have this idea that you have to scroll in Visual Studio or Visual Studio Code to see the rest of your code for the function is too long. Right? It's not exactly always like that, but it's a good sort of rule of thumb. So they're that simple because they do one thing. It's called an Azure function, not an Azure functions, right? And because they're that simple, the integration test should be similarly simple. So if you have, say, an Azure function that every 10 minutes looks at a database table to see if there are tickets that are more than 2 hours old and then expires them, for example, well, you should have the integration test should just test that. It shouldn't test what happens, how does an expired test then look like somewhere else, or like you should just make them simple. And again, integration tests are by definition not always simple, but that would be my first thought, is to really just keep it simple, because integration tests are hard.
Okay, next question is from me. So that first tool you showed in Azure DevOps looked pretty heavy for a developer tool with all of its test suites, test scripts and stuff. It looked like, one of those old school QA tools. Do you find developers actually use that one a lot, or does that kind of thing get shuffled off to a QA? It was
hang on.
Sorry, I should have written it down. It was when you had all the options down the side, and then there was the tests one, and then there was a whole bunch of tests underneath. Hang on. Man, I don't know. I need my glasses to see your tiny little screen there. So under there, test plans, test scripts, and it's like, test cycles. I've been here. They used to be in spreadsheets. I'm like, if I was a developer and I saw that, I'd be like, no.
Yeah, well, and you absolutely will. That was my initial thought as well. And it's the same with application insights, for that matter. Application Insights is crazy scary when you first open it because there are just things you can click absolutely everywhere. It's a bit like how do you eat an elephant, right? You just do one bite at a time. So if you see this and it sort of go, I'm not using that, I don't know where anything is, you wouldn't use all of it. Like this Azure DevOps are 5 big tools in one platform. So Azure Boards is a full management tool. It has swim lanes and agile and graphs and tasks and integration points and blah, blah. It has all of it. And the same in all the others, right? So you wouldn't use all of them. Repos is where you find your code. So for test plans, if you are, I think this is more designed for people that are actual test engineers, but that doesn't mean as a developer, you can't write tests that go in there, right? My point with showing this was that, hey, you can set these things up. And you can test your code automatically on every single thing. You have test plans that run as often as you like. But yeah, it is, well, some of these tools are just massive. I think that's the best approach is always to try one thing and figure out what that one thing does, rather than trying to understand everything in one go, I think.
It's not the whole tool with the setup. It's more like the way it's set up with the, I just saw test plan, test script kind of thing. And I was like, that's now smells like a QA.
If you're in a bigger team,
doesn't smell like a development
If you're
tool.
in a bigger team, if you're in a bigger team, you wouldn't necessarily get access to all of it either. You would just have permissions to see what's relevant to you, right? So yeah, it can be daunting. And I know as developers, we just want to write code, right? It's sort of like, I can't be bothered with all this. Just, give me some bits and bytes and I'll write some code. But it's there.
Cool. All right. Another question from Anonymous. How do you balance cost across all of these testing services? How easy is it to integrate open source alternatives with Azure?
So it's sort of 2 questions, but it leads into the second one. But I get the link. Well, cost as always on any cloud provider. I would say, and I might be being a bit biased here, but Azure is slightly easier than AWS in managing costs. Something like AWS's free tier is not actually free. Those things, that scares me. But again, I'm not an AWS engineer, so I might be getting that just a little bit off kilter. For Azure, alerts, billing alerts galore. Make sure that things can't go over a certain level. Policies, as boring as it sounds, policies is one of the best features on Azure to manage all this. Azure Policy is the service, but you can set up, you can only create this type of VM that is only so much or whatever. You can set in policies about auto shutdown. You can have policies that only enables people to create a certain number of regions, for example, because some regions are much more, expensive than others. And then on top of that, use alerts. Absolutely have billing alerts. We all hear about the horror stories of, oh crap, it just spent $2,000 overnight, right? It doesn't happen very often. It really doesn't. So, but yeah, manage the cost by using those 2. So billing alerts and Azure Policy would be my suggestion. Oh,
what about the
open source?
The second part was, how easy is it to integrate open source alternatives?
Into what? To everything, or?
I assume other testing tools into some of the Azure stuff.
Yeah. So Azure DevOps itself talks to anything. Like you can use almost any tool with it. It has tons of webhooks and APIs that you can hook into and use. It connects natively, like through the interface here. It connects with all sorts of third-party tools, whether they're paid or open source. I don't, if you have a specific one, you can sort of maybe try and figure out if that works. But in general, everything just works. It's sort of like if you haven't looked at Microsoft for the past 5-10 years, there used to be, hey, you have to buy our stuff or we don't help you. Now it's like, we don't care as long as you buy Azure credits. It's sort of shifted that way. So you can almost take anything into Azure, right? So, and that's sort of the paradigm shift, is that you can use almost anything. Everything AWS works with Azure DevOps as well. Right? So